So let's talk about these operations. So we talked about the concepts of addition, subtraction, multiplication, and division. And so we talked that addition can be thought of as like a part-part whole model. Addition can also be thought of as a join model. And all of the other operations have multiple ways for us to think about them conceptually. But now let's think about the procedures that we might use when we're presented with multi-digit problems where we have to add, subtract, multiply, and divide. Now, place value is a really important concept that a lot of students have difficulty with. And so place value, if you want a good definition of it, we could call it the system by which the value of a digit is determined by the position it occupies relative to the decimal point. So let's look at this whole number here, 604. So this number has three digits in it. We have a 6, a 0, and a 4. The 6 is in the hundreds place. So this 6 doesn't represent just 6, it's actually 600. And this 4 is in the ones place. So it says that this number has 4 ones in it. So I have to be able to look at this number and interpret what does this 6 mean, what does this 0 mean, and what does this 4 mean based on the place value of that digit. And a lot of students have difficulty with this because they've been exposed very often to single digit numbers, and then we start to throw in double digit and triple digit numbers just like this one pretty quickly without providing a lot of place value background for students. So here are two other whole numbers, 16 and 2,309. Students should be able to name the place value of each digit, so be able to tell you what is in the thousands column, the hundreds column, the tens column, and the ones column. And they should also be able to have opportunities to use manipulatives to show you what these numbers actually mean. So I'm going to go over here and use the base 10 blocks, and I'm not going to do 2,309 because that's a really large number, and I actually didn't even bring that many blocks with me today. But I am going to focus on the number 16 and talk about some of the things we need to think about when setting this number up with manipulatives. So our number was 16, and when I'm working with the base 10 blocks, we have our rods, and you can call those tens, and we also have our units, we can call those ones. Things that we should not call these are not cheese straws, these are not French fries. We want to be mathematically precise with the language that we use with these manipulatives. So you should call them either rods and units or tens and ones. So let's go back to our number. Our number was 16. So 16 has one 10 in it, so I would put one 10 rod right there. And then 16 has 6 ones, so I'll place 6 ones to the right of my tens. So here I have 10, 11, 12, 13, 14, 15, 16. 16 is 1 10 and 6 ones. Notice when I'm using the manipulatives to help students understand place value concepts, I'm placing the manipulatives in the order that the abstract number would be written. So if I were to write 16 below this number here, the 1 is here, so the 110 is to the left of the ones, and the 6 is here, which means the ones are to the right of the 10. So this represents 110 and 6 ones, or the number 16. Now when we're showing other numbers with the manipulatives, and we'll go back to our place value mat here, when we're showing, it's really helpful to have a mat if you're doing anything, any numbers that use the hundreds or the thousands. So here's an example place value mat that we've used with some of our students in intensive intervention before. And you can use manipulatives with this mat, but you can also just do representational drawings on this mat. So you can actually draw the hundreds, tens, and ones. There's stickers that you can use, and if you don't want to do the drawing, there's a lot of virtual manipulatives that you can use. Just download those on a tablet or computer, and you have a whole set of base 10 blocks that you can use very quickly to represent each of these numbers and the place value within each of these numbers here. Now, I'm not going to spend a lot of time on place value, but I just wanted to touch upon it here today to really make sure that when you are providing intensive intervention, that you're thinking about the student's strengths and weaknesses. And if they seem to have a weakness with interpreting numbers and interpreting the place value of numbers, you may want to really do more place value activities than your program provides for you, because we know the students struggle with place value very often, and so you might need to provide some additional support in that area. Another area for additional support while we're thinking about computational procedures is how we actually set up our math when we're doing it on paper. So here's a problem right here, 46 plus 13. Now, this is an example that I chose just because it fits nicely on these slides. But when students start to line up numbers that are triple digit numbers or quadruple digit numbers, a lot of these things that I'm going to talk about are very important to do. So it might not seem so important with double digit numbers, but it's going to become much more important later on with those larger set numbers. So students often with these abstract problems have a hard time keeping everything aligned. And so some of the things that we can do is that we can help students keep their work lined up by having the students write on graph paper. So here you can see students put in one number for each space on the graph paper. Another oldie but goodie is turning notebook paper sideways and then rewriting the problem there. So here I've got my tens column all lined up for me, and then over here I have my ones column all lined up for me. I can also do a combination of those. So here's graph paper with a highlighter as to maybe where to start or where to end. And finally, I could do something, and I've seen some teachers do this, where they'll use a bookmark to cover up the column that you're not really focused on. So here I'm focused on the ones, and then I'm going to move to be focused on the tens. So what these ideas help us with is that once we are going to get into procedural algorithms, it helps me organize my work, because a lot of students may have misconceptions with like what's going on with the math, but a lot of students may just make mistakes with the organization of their mathematics. So we've got to help them get organized. And then another background thing that we may need to provide in intensive intervention, along with understanding place value and getting your work organized, is understanding the concepts of regrouping. So when we're thinking about regrouping, we can regroup 10 ones for 110 or 10 tens for 100. And I didn't put it on this slide, but we could also do 10 hundreds for 1,000. All right, so understanding that there's a go back and forth between these tens and ones or tens and hundreds. Now, when I was in school, I learned this terminology as that means you're going to carry. But that is really just a procedural term that doesn't tell us about the mathematics. And so these days, we need teachers to use one of these three terms. So instead of saying, oh, I carry 10 ones for 110, which actually doesn't make any sense whatsoever, you would say, I regroup 10 ones for 110. I trade 10 ones for 110, or I exchange 10 ones for 110. Those terms make a lot more sense. They're more conceptually based, and they really tell the students what's going on between the tens and the ones. Carry doesn't mean anything like that at all. So that's why I covered it up. You can't even see it anymore, so hopefully it's out of your mind. With subtraction, we also have some regrouping things that we need to think about. So we've got 110 for 10 ones, or 100 for 10 tens. And probably some of you are used to this term borrow. I'm going to cover it up very quickly here because we want to make sure that students aren't saying borrowing. That doesn't make sense. It's a very procedural term. Instead, we want to focus on these conceptual terms of regrouping, trading, or exchanging. And what you will notice is that the terms that we can use in addition are the same as the terms that we can use in subtraction. And I like that idea. It makes sense because I'm regrouping 10 ones for 110. And the same way in subtraction, I'm regrouping 110 for 10 ones. It shows the relationship among these different units of place value. So as we go today and we focus on some of these computational algorithms, I'm going to really focus on using the correct language. So I'll most likely use the word regroup, but you remember you can also use the words trade and exchange. Now, why are we focusing on all of this stuff around procedures? So when we're thinking about computational procedures, they really have to be taught in conjunction with the concepts of the operations. So in part one, we talked about the different ways to interpret addition, subtraction, multiplication, and division. And now we're thinking of like, okay, for larger set numbers, what are some of the procedures that students have to learn in conjunction with those concepts that'll help make them a successful mathematics student? So this is really just filling up your toolbox with more tools. You might use some of these tools with some students and other tools with other students, but the idea is that we're increasing your knowledge about this so that you can align the intensive intervention instruction to fit the student's needs.